Solution A is the iodine solution, and to make it I took 2 grams of potassium iodate and I placed it into this bottle here, and I added 1 liter of water. So that gave me my solution A. Solution B is the one that has the starch, and here I took 2 grams of starch and I put them in a little beaker, and I added a little bit of water, and I made a paste with it. And this paste was then used to dissolve the starch. And then once it had an even consistency, I added a liter of boiling water. And then I stirred it and let it stand and cool down. When the solution had reached normal room temperature, I added 0.4 grams of sodium metabisulfite and 5 milliliters of a 1 molar sulfuric acid solution. So in here we have starch, sodium metabisulfite and sulfuric acid. Hi, good morning to you all. My name is Detlef and I'm a teacher, but I'm now a product specialist for BMS education. I have been teaching for many years, and at the moment I'm involved with the outreach program for BMS education. This is a tool which includes blended learning, and this is to help the teachers in their work. Now, science is a very interesting subject and it's great fun, but besides that, science is important in the future career. Most professions like engineers and doctors will need science. So let us encourage the children to follow this path. Today we are going to focus on 2 experiments. One of them is for grade 11, and this experiment deals with the rate of reaction in chemical reactions. And the other one is for grade 12, which deals with the internal resistance of a battery. Some concepts in science are difficult to understand, and we find that it is far easier to remember if the learners can see and do. A hands-on experiment is a far better way of teaching than just a visual one. What we at BMS Education have done is we have set up kits for these 2 experiments, and they contain everything that you will need in the classroom. But what I always tell the students is that there isn't much to learn in science, but there is a lot to understand. We do this through a concrete representation of an abstract. Putting all these components together can be quite complicated, and we are here to assist you in getting them right. Now these experiments coincide with the CAPS practicals that have been prescribed in the syllabus. I need to heat the solution to 40 degrees, and then at 40 degrees I will introduce into the beaker these 2 test tubes. One of them's got solution A and one has got solution B, and I'll leave them there for 5 minutes so that the liquid gets the temperature of the water, which is 40 degrees. So we're doing the reaction at 40 degrees. Here we're doing the reaction at 0 degrees, and the third one we're doing at room temperature, which at the moment is about 20 degrees. So we now have the solutions at room temperature, and we are going to add them together, and we're going to see how long it takes for the reaction to take place. With the timekeeper ready, and we're going to go now. So the time for this reaction was 6 seconds. Okay, right now we've got the solutions that have been in this ice water for a while. The temperature of the solution here is 0 degrees, and we're going to time it to see how long it takes to react. Okay, and that is now 8 seconds. 8 seconds, which is longer than the room temperature one. I've taken the temperature here, it's 40 degrees, so we're now going to time it for 40 degrees, and we're going to start now. And that was 4 seconds. Compare that with the room temperature was 6 seconds, and the cold water, which was 8 seconds. Please feel free to contact BMS Education for any other resources that you may require.